Hello, my name is Tudor Gerba. I am the CEO of Think. At Think, we are concerned with making the Internet of Software Systems explainable, and the flagship technology that we're building is Glamourous Toolkit. That's what I want to talk about today. And specifically, I want to talk about version 1.0, which is about 6 years in the making. And we've just released it today. And when people approach Glamorous Toolkit, they look at it from different perspectives. And I would like to browse those kinds of perspectives with you to start with. So, of course, Glamorous Toolkit being implemented in Faro, it can be perceived as a Faro development, and for good measure. Here, for example, we have a Faro development environment, or a Faro browser, or browser for Faro code, where we are looking at the GT Ludo game class, and here we have a number of methods. We see familiar things for those that are familiar with Smalltalk syntax, like a typical editor for methods. What is maybe less familiar is the fact that we can maybe take a look at multiple of these methods at the same time. And even perhaps more intriguing are these kind of little triangles over here, which are actually added by the syntax highlighting as we type. And once we have a triangle like that, we can simply just expand whatever we have in front of us, whether these are classes or methods. But there are, of course, some other things that we can do in a Faro environment is looking for implementers or senders. So here I am looking for the senders of a method, or maybe for this other one. And I can see here on the right a number of results, right? I can see that there are some things in examples. I can scroll through them and see some other examples that I have just even recently ran. So what are those? And I can just expand them in place. And so here I am looking at this example. I can see move token named has been recently, or this is what I was looking for. And because this is an example method is like a test case that actually returns an object. And because this is an example method, I actually get these extra buttons, right, that I do not see in other methods. But because examples can be executed, I can also run them and get the result. So here I am obtaining an inspector by of an instance of the GT Ludo recording game. And this inspector here now shows me the board of the game that is actually a preview of the actual thing that the user is interested in, except that I'm now getting it in the most basic tool that I have in my environment, which is, of course, the inspector. Of course, typical inspectors look like this, but we don't like to look at objects in that way because it's rather poor. It's very generic, but rather poor. So rather, we'd like to have custom views that show us interesting things about objects. And of course, what is interesting? And interesting is always contextual, and therefore, tools have to be contextual too. So, but I can see here that there are multiple of these kinds of views. So why? Well, one of the things I can see, this is a game, and because if I read this example here on the left, I can see that I rolled a 5 and I moved a token called B. And this came after on top of a different example that I can expand, and I can see that there I had other moves. Of course, I can read the code, and because this is a fluent API, I can kind of build a mental picture of what that is. But a different way of looking at the same data structure is exactly this. I can take a look at the object, and the object now tells me what kind of moves were there. And when I click on one of those moves, the move can tell me what the move did. So I'm basically having a normal development session. This is how our normal development sessions look like, all of them. We always program in the presence of some sort of representations that we have in mind prior to working. And we want to make our environment match that representation. And of course, sometimes you want to look, for example, at moves like this so I can see which players did what. But sometimes I just want to have fun and I want to look like this. So Of course, Glamorous Toolkit is a Fire development environment, but you can already see how it's actually quite different in terms of an experience from a classic Smalltalk environment. Now, a different way to look at Glamorous Toolkit is to look at it from the perspective of what you can document, so system documentation, to look at it as a system documentation platform. So indeed, Glamorous Toolkit comes with significant book documenting Glamorous Toolkit itself. And this book is actually written in not just text or pictures, but is actually filled with live objects and code. And the book is actually delivered, of course, right in the environment. And so here's one of them, one of the pages in the book. You can see here on the left the table of contents. And one of the pages in the book is documenting the very game that I just showed you, which is actually a case study that we have built and played with in order to teach people about this new concept of moldable development that Glamorous Toolkit enables. So if I look at this, right, I can see the board that I have seen before, but I know that that board was actually obtained from some sort of an object, which, of course, there was a view on top of that object. So where does the object come from? And the object comes from the example, right? That thing that I have used to test, to implement my test-driven workflow, except that it's not just a test, but it's actually a source of interesting objects that now I know have interesting properties, and those interesting objects have interesting views. And once those interesting views exist and the objects exist, then I can compile them very quickly in interesting documentation. So for example, here I am documenting, offering a documentation for an end user about how the program actually, or how the game actually works. So yes, so system documentation is also a reasonable perspective to regard Glamorous Toolkit from, but equally interesting is to look at it from a personal knowledge management perspective. So indeed, here I have a page from my own personal knowledge page. The technology there is called Epiter. And this page here is actually the very notes that I took for this particular talk. And I can see here that I have my notes and I have my pieces of code, and even the kind of code that I should load so that my image is ready for this particular talk. But one of the interesting things, let me close those notes because they look messy, and this is what it should be, right? Personal knowledge management is not particularly structured, or sometimes it is, sometimes it's less structured, but your environment should welcome those. But here there's an intriguing thing. I have here a little snippet, which is not a text snippet, it's not a code snippet. It's actually a snippet for connecting to Blue Sky. Blue Sky is a social network. So here I wrote a piece of text, and I say Glamorous Toolkit version 1 is out. And when I press on this OK button, it actually is going to publish it, and it's going to publish it for this user, tudorgerba.com, which is my own. So you can now go to Blue Sky and see this very post has been posted. And of course, from there, I can go and then create a thread. And then I'm going to tweet or post another message that comes as a reply to this one. Which now, the interesting thing here is that this is an exercise of empowering humans to deal with technology in a way that does not happen on the terms of the service providers. Here I have an interface with which I interact with the service, but that interaction happens in my terms, in my private space, the way I want it. And how do I want it? Well, the way I program it. So yes, personal knowledge management can also be a way to look at Glamorous Toolkit. But a different way is like other people, they come and they look at a more typical use case, which is like API browsing. So if I look here at another page from another knowledge base, I can see here another snippet. But in this case, it is a snippet that allows me to actually log into the Blue Sky social network. So once I log in, what happens here is that I get the results, and I get the compact posts, right? And I can also get the postcards like this. And then, of course, I can go in there and I can see the post that I just made, right? The Glamorous Toolkit version 1 is out. It's right here. And I can scroll through others, and I can go and inspect those if I want to. Now, interesting here is, right, there's no, in this particular social network, there is no explicit notion of a thread. So one of the interesting things here is to say, well, actually, could I somehow get the top posts, those posts that have no that have at least one child that I have posted, and so that I can see what kind of threads did I post there. So here I have a little snippet here, but in this case, this snippet is executing against the server, and it retrieves a stream, and the stream also knows how to draw itself. And I can see here, I have this notation with /1 or 1/, which is actually the root of one of my threads, and I can see that this is I only got those. Again, I'm making a query over the system, but the query does exactly what I want. So that's another way of looking at Glamorous Toolkit, being it an API browser. A different way is which is something that is used for analyzing or making sense of code. So here, for example, I have an inspector over a folder called Zooniverse, which holds an implementation of a JavaScript system. I can take a look at that. And I can browse, and I can see, oh, here's another reference over the JavaScript, but in this case, the code is also highlighted right there. I'm not going to go into the details, but this is actually a React Native application. And those React Native, they define, so there are components being defined, and then we can take a look, like you can combine, they combine those components. One of the interesting things when you combine components is how is that composition happening? And that's a little bit of an issue. And in fact, when we played once with a little React Native application, we quickly got into this problem of cyclic dependencies between components, and we looked around for tools, React being the most used framework on the planet. We thought others might have gone into this problem as well, and they did, but it turns out that there are little tools to help make sense of those cycles. So what do good engineers do? They're going to build the tool, and that's exactly what we've done. So here, for example, I'm not going to look at this system, at this directory as just a plain directory, but instead I'm going to transform this one a little bit, and I'm going to get a moose model here. And this moose model, we're going to have some React components, and of course, those React components will have a dependency view. And then, of course, once I have a dependency view, I can click on any of these, and of course, I can get the source of it, which then transforms this whole little thing that I have there in a very dedicated code browser, but it's very, very cheap to put together. So yes, software assessment or reasoning about source code is also a different way to see when you're looking at Glamorous Toolkit. Now, other people that look at Glamorous Toolkit, they see the graphical stack, because this is a different graphical stack than what you're normally used in a FAR environment. And it's true, because we have actually built it from scratch, and it has kind of interesting properties too. It's not just another graphical step, but it has this property which we call one rendering tree, in which everything that you see on the screen is actually part of a single data structure, a single tree. And that tree, like for example here, we have a famous application with people explaining the Smalltalk syntax. They would typically use this example with number and some sort of made up code there that has most of the constructs, except it misses a few that we can see here. But of course, now we can see which of the constructs and how they are represented just in this kind of interface. Now, this interface happens to be inside this knowledge base, but notice how the lines go from outside the editor to inside the editor. And this is not just happening like that, because if I remove this thing, then certain certain things will not work. So the return will not be there anymore. So it's actually live. That line happens. So this is only possible if you have the same environment. Like you cannot embed arbitrary renderings one in one another and then expect them to seamlessly work. So the graphical way, the graphical environment being kind of unique and allowing us to have all sorts of interesting representations, such as, for example, seeing the preview of something embedded directly in the editor, is another way of observing, another thing of observing when first time you're encountering Glamourous Toolkit. But then, of course, that's just, until now, we just talked about the kinds of things that you can do with an, a Faro virtual machine, a Faro runtime. But you can also, there are other ways, there are other kinds of systems that we can interact with, so Gemstone being one. And of course, I can do here I have a Faro snippet, and I'm going to interact, I'm going to execute that, and I'm going to say, oh, give me the system stone name. And it gives me the system stone name. So I already have locally a Gemstone running, and I can execute this code remotely, which is the normal way of doing things when you're working in Faro, except that that's not a nice, it's not a nice experience to program in strings, right? So I kind of would like to see proper syntax highlighting or tool support. So here there's a Gemstone, a specific dedicated Gemstone snippets from which I can just inspect and I get the same thing. But then of course, once you're doing that Gemstone instance, what I want is actually, let's see what happens when we inspect some object, some domain object in Gemstone. So in this case, I'm inspecting here the result of multiple users' paths, so geolocations throughout time, which comes from a Microsoft Research database. And so here we'll just look at 25 of these users. I can take a look at those like that, or I can take a look at the users in this way. I can pick a user, and I can see here on the right that I have these, for example, the trajectories. And now, of course, when I look at these trajectories, let's actually execute a code and say we just want those trajectories that have more than 10 kilometers, because maybe only those are of interest. And then so I'm going to write here a normal thing where I'm going to do a select over my collection. I'm going to wrap it in a nice little tiny domain object so that it has a nice view. So when I execute this, I'm just going to get 55 items out of the 115. And then, of course, when I select one of those, I'm going to get a specific trajectory. I can see the path there. And when I'm going to select one of them, I can see where it is on the map. This data set actually comes from China. So, or I can see the preview of it, which is actually retrieved from the OpenStreetMap. Now, here's the thing. Here, I'm not showing you objects that are living in Faro. All of these objects, they actually live in Gemstone. And yet we still benefit from these custom views. Some of these views actually are serialized directly from Gemstone, so computed on Gemstone and serialized back to us. And some other views, like these two here, actually live on the client side. So you can choose how you want to program things. Even more, sometimes, when you work with this kind of remote environments, it's very nice to work with them, but sometimes you want to test them. So sometimes you want to take this object and bring it locally. But that's exactly what I've done here. I went from a Gemstone object to a local Gemstone, object. And then, of course, the same object has the same views, which is kind of interesting. So I can play with them. Okay, so Gemstone is another thing, but actually, why stop at Smalltalk syntax? Here's, for example, we're a browser implemented in Glamourous Toolkit, and it's available in the default distribution, which is actually a browser of Rust. Yeah, the Rust, the programming language. In fact, why Rust? So one of the reasons is that a good deal of the plugins that are actually shipping with Glamourous Toolkit are actually implemented in Rust. So what can we do with it? Of course, when I type, one of the things I would like to get completion, of course, right? So here it is with completion. But other things that I would like to do is I would like to look at senders, for example, which I've just done. So I get the references list. And when I click on that, I come back to my editor, and in this case, it is highlighted. So this is no longer working with just Smalltalk, and it's not just some foreign runtime, but it's a different language. And that's because underneath Glamourous Toolkit, there's also a language workbench. Now, all of these are reasonable perspectives, and they're correct, of course. But at the same time, they are all wrong. Why? Because when people look at Glamourous Toolkit, they expect to see tools. And indeed, they could see tools I could click on and do some job. But the way we look at it is that actually there are no tools there. They are just instantiations of a more generic environment. And this instantiation, because we have this more generic environment, we consider the environment to be the language. And so once you learn the language, you can start to use them in many, many different ways, in ways that are not prescribed to you in any shape or form. Of course, that was the intent of Smalltalk from the very beginning. But then the question is, how far did we come? And in our case, we wanted to explore, we started Glamourous Toolkit to explore this one idea. What happens when we're going to look at every single development problem that we're going to encounter through the lens of a custom tool? And the result that you see here is exactly that. It's an environment that has been systematically constructed through custom tools. And because we systematically use it as well, the environment now made it incredibly inexpensive to create these kinds of tools. So why is this interesting? It's because we don't go to tools. Tools come to us. And when tools come to us in our context, we can choose exactly the combination that's going to fit exactly the moment we're in. So I'm going to give you some examples of this. We can combine arbitrary things in any way we want. So for example, here I have an editor, and I have an example that shows me the selection over an editor. So I have an editor here. I move the cursor to position 6, and I'm going to select something, and I'm going to assert something. I can imagine this by just looking at it. But what if I can do this? And so, of course, I still have the editor, but the editor is not enough. I wanted to decorate the editor as well so that I can actually see what the index is. Why? Because that makes debugging pleasurable. Every single bug is an enormous source of joy, if you look at it like that. So, now, of course, the interesting thing is that every single detail in our environment, that's one of the things we've learned, every single detail in our environment can actually be made incredibly delicious. And, but it doesn't have to stop at Smalltalk. So here I have another example here when I'm going to build an editor. Now, these editors, if you think about it, it's actually built on top of a Rust wrapper, which is going on top of another library. So the low-level management, we have actually two backends, one implemented in Faro, which is slower, and one is implemented in Rust, which is much faster. And so, of course, when we inspect things, I can see all sorts of things about, for example, I can see the segments of this. There's exactly one of them, one paragraph here of this text. But I really would like to get a hold of that little tiny Rust object that actually holds all the juice. And so here it is. I'm going to inspect now the same thing, but now implementing this lower wrapper. So here's, I have a paragraph object. This is a Smalltalk wrapper over a Rust wrapper. So when I look at this one, I can press this button here, which is an R, and I'm going to get an inspector over the living Rust object which is living in the plugin, which is managed by the virtual machine. And so here I have a paragraph object that is actually living in Rust, and this view over here, if I alt-click on it, I actually get to see the view. The view is actually implemented in Rust, and yet it lives and it appears live in my environment, across languages, across borders. Because all those limitations, everything that happens in a computer, there are no balls. We made them up. And we don't have to train our brain around the worlds that we have created artificially. It's up to us. And we actually, we use this view. This view didn't come up from nothing. We literally used it to actually debug a problem that we fought with for a long time. Because indeed, we also fell prey to the same impulse of saying, well, Rust is a different place. I'm going to build my little world, my Smalltalk world. And I'm going to build my tools for that Smalltalk world. And it's going to be so nice. But the reality is that there is a world out there too. And why shouldn't we welcome that world in our little nice world? And that's exactly what we've done. Now, the thing is that here we had a bug, and this bug existed for 6 months, and we literally couldn't build. We couldn't figure out where the bug can come from. And the bug was due to the fact that here you can notice here that there are line ranges. So that paragraph was split into line ranges so that it can appear on the, like here we have 1, 2, 3, 4, 5, 6. So you can see those 6 lines over here as well. Now, interesting enough, here we have a range coming from 0 to 38, and then from 38 to 70. And we assumed, when we read the code, which is not an unreasonable assumption, we assumed that there's an interval with that also includes the extremes. And it turned out, once we looked at this view, it became obvious that 38 cannot be in 2 places at the same time. So the finding that bug became seconds. That's it. That's the power of a custom tool. And this idea can be applied absolutely to every single problem we have. And sometimes we apply them to weird problems like this one, or sometimes we apply them to situations where we're looking here again at our we're looking again, if I look back at this, at my editor, right? I look at a detail that nobody will ever see except me, the creator, or somebody that is creating it. And that's exactly the beauty of it. There is no reason. If we've learned one thing from Smalltalk, is that computation can be made explainable to a large population. In fact, right, that's why they started with kids. Now, the other thing that we've learned from Smalltalk is that you can express an environment in a uniform manner. Beautiful ideas. Why not combine them? Because it follows that if you can make some level explainable to somebody else, you can make any level explainable to somebody else. And therein lies this idea of moldable development. The idea is that we can make the inside of software systems approachable, understandable by normal humans. We are literally applying this. The result that you're seeing here is not an abstract experiment. We're a company, and we earn our funding by actually solving hard problems. Hard problems for which people do not know how to find the answers. And we don't know how to find the answers either, except after we build tools. And those tools, they don't focus on the solution. They focus on the problem. Because bugs and any problem inside a software system can literally feel delicious. Now, the other thing about Glamourous Toolkit is that it comes with a ridiculous amount of examples inside. It actually comes with a sizable documentation as well. And that's a different perspective that is sometimes escaping people. That Glamourous Toolkit is not only a moldable development environment, it is also the most elaborate case study of moldable development we have so far. And to get you this idea, here's a visualization of the Glamourous Toolkit code base with two highlighting colors. In blue, we see the classes. So this is a visualization showing you a tree map of packages and of classes in those packages. And in blue, we highlight the classes that have at least one custom view, an inspector view, at least some sort of an extension. It could also actually be that they are debugger extensions or search extensions or editor extensions. And with green, we see the example classes that exist. And what we see here, and this was one of the things that actually surprised us too, rather early on, that this idea of custom tools applies to every single development problem. So we've built Glamourous Toolkit to explore how far it goes. This is how far it goes. And so now it's up to you to take a look at it and perhaps learn from it. Thank you. Yes.
Of what is already implemented in GT. I mean, if there is, in my case, I'm working with a proprietary language. For that, I will not find a parser. I have to do that. How is that? Can you elaborate on how is that process when you reach the borders of what is actually implemented in
Glamorous Toolkit comes with literally thousands of extensions. And with those thousands of extensions, we can probably tell into millions of stories. So any given set that I will explain with will always be suboptimal. This is why we built a live environment. Now I can tell you this, specifically to your answer, what happens, for example, when you're tackling a technology for which there is no tooling. This whole environment didn't exist 6 months ago or 6 years ago. And we built it by actually just applying the same principle over and over again. Now, of course, it so happens that we were focused on trying to figure out systems implemented in other languages. And for that, there are actually 2 technologies, depending on how we deal with those. But all of those technologies actually also have tool support there to build for all levels of abstractions. And of course, will that tool support be enough for a given situations? Most likely not. That's why we're going to say you should probably build your own as well. But I do invite you to take a look at the case studies that we've built with Glamorous Toolkit, specifically in the area of parsing. There are a number of parsers already implemented, but actually just take a look at the classes that exist there, and then the tools that are surrounding them. For example, how do you debug a parser? It's an interesting problem, right? Whenever you're building a parser for an unknown language. And yeah, let's start the conversation from there. Yes, another question. Do we plan to do some marketing campaign about the first release? One of the things that we're definitely going to announce, or we are announcing it, and we have documented it, which was one of the main reasons why it was not announced earlier. But one of the things we have learned, so for example, we as a company, we work with exactly 2 kinds of companies, or 2 kinds of organizations. Those that have a crisis because they don't ask how you get them out as long as you do. And those that are seeking competitive advantage. They are already convinced. So at this point in time, we're actually focused on the latter. We're focused on those that are seeking competitive advantage. Because we believe that they will be the ones convincing the other ones once the competitive advantage becomes more obvious. Yes?
Do you have any ideas or have you thought about the debugger?
Yes, again, the debugger is also quite highly extensible as well. So as I said, any given set of examples I will provide in any finite amount of time I have for a presentation will leave something that is not shown. And the debugger is one of those. This idea applies to the way we debug, to the way we edit. The editors are also extensible and can be programmed as well, the way you search, and several others. Thank you.